Hello friends, welcome to another video, and in this video we will discuss one more advanced coding question of TCS NQT. So this question is repetition of another question that I have already discussed in my previous videos. So there was one question in which we had to find the maximum amount of gold coin that can be collected. You can go through so many of you must have gone through that question. So in that way we had to find the length of the maximum subarray with sum exactly equals to k. So that was the question there. So here the question is a little bit different. So here we had to find the length of the maximum subarray with sum less than k. So there it was exactly k, here it is less than k. So all the algorithms that we are using is same. So we will be using sliding window and everything is same, just a slight different. So this question is very important for all of you. Try to understand the question, and this is very popular algorithm. So there could be many questions that can be asked on it. So try to understand it. Okay. So here we will see the code in Java, and I have already discussed the same question with Python also and C++ also. So whichever language you are good in, you can go there. Okay, so for now we will discuss this one. So this is the lengthy question. You can pause the video and try to read the statement. Then we will move to the solution. Okay, so I hope all of you must have gone through the problem statement. Now we will try to see the question. So the question is like this. There is a person named Bob and he has k amount of money with him. And now there are n horses and each horses there is some price. If you want to put a bet on that horse, there is some amount of money you have to spend. Now Bob has k amount of money, so he wants to spend that money and he want to put a bet on maximum number of horses possible. But there is one condition, that the horses should be continuous. So you have to find, he will put bet on continuous horses until his money is exhausted. So we have to find that length. So basically in simple word, the problem statement reduced to here. Let me show you where it is. Yeah, this line, just this highlighted line, can you see it? So just we have to find, can you please find the length of the maximum continuous sequence of horses on which Bob can make a bet, and remember he will invest money less than k unit. So just we have to find the length of the maximum subarray. Okay, so I hope you understand the question. Now let us try to go through the input. So input is like this. So this will be the number of horses. This is amount of money Bob has. So in this case he has 100 rupees. These are all the horses, that is price on that horses, and he can spend up till 99 rupees because he can spend less than k. So less than 99 and less than 100 is 99. So he can afford up till 99 rupees, and he want to put bet on maximum horses, and that should be continuous. So it is like this. He will start from here and he will put bet on this one. So he spent 30 rupees. Now still he has some money left. So he will see, can I move ahead? So he can move ahead because putting bet on both these horses, he need 70 rupees and he has that much rupees. So he can go, but he cannot move further because the moment he will move further, he needs 70 plus 50, which is 120. So if he want to move further, he need 120 rupees, but he does not have that much money. So starting from here, he can only go up till here. So this is one possibility. So in this case, the maximum length is 2, continuous. Now starting from first horse, there is no point in moving further because he do not have money. So what should be another possibility? Now he will think, okay, from here I can go up till here. So now let me try starting from second horse. This is another possibility because we want maximum and it should be continuous. So now he will start from second horse. So 40 rupees. Yes, he can afford. Now 40 plus 50, 90 rupees. Still he can afford because he has 99 rupees. But the moment he will try to put a bet on this horse, he need 40 plus 50, 90 plus 20, 110. So he does not have that much money, so he will stop. So two things we have seen. Starting from first horse, he can go here. Starting from second horse, he can go up till here. Now next possibility is he start from third horse. Now see how far he can go. So he will put bet on this horse, 50 rupees, plus 20, 70 rupees, still he can afford, plus 20, 90 rupees, still he can afford. The moment he will move further, so 90 plus 10, 100. And as I told you, he can spend less than 100. So he cannot move ahead. So now the length of the continuous subarray is 3. And we want maximum. So now our answer will be 3. And now he cannot move further. Next he will try from here. So 20 plus 20, 40 plus 10, 50. Now he cannot move further. Here also 10. Next he will try from 20. So 20 plus 10, 30. Cannot move further. Next he will try from here. 10 plus 90, 100. Cannot move. Only will go up to 10. Next he will try from 90. So in this way there is one more here. Here also 3. So he will try all the possibility, and the maximum you will find is 3. So this is the question. I hope all of you must have understood. So this length we have to find, and that should be maximum. So I hope you understand the question. Now how we will solve this? What should be our approach? So here comes the sliding window algorithm, which says that suppose we have new test case here. Now he has sum or amount of money 12. So he will start from first horse, will put the bet, then move to second, then third and fourth. So up till here he can afford. 4 plus 3, 7 plus 1, 8 plus 2, 10. So he can afford. So starting from first, he can go up till fourth. The moment he finishes, now what we want? We want to start from second. And again we'll try to calculate. Okay, again we will see, okay, start from second, calculate 1 plus 3 plus 4. So what sliding window says that if you start from second, so no need to recalculate. If we will try to recalculate, we need 2 for loop. So our time complexity will be high. So what it says that within 1 for loop we can do. So if I ask you, okay, now start from 2 and calculate all again. So we need 2 for loop. So if in question there will be given time constraint, it will be wrong or TLE. If it is not given, then you can pass this. But if it is given, then within 2 for loop, it will be TLE. So it's advisable to solve within 1 for loop or 1 loop, or within time order of n. Okay. So what sliding window says that suppose I have calculated sum from here to here. So it is 10. And we have checked, okay, 10 is less than 12. But we cannot move further. So now we want that starting from first element, we cannot move further. So another option is start from second element. So again we have to find the sum. But sliding window says that if you have already found the sum from here to here, then you already have the sum from here to here, because this one is just a part of this one. So if I have sum from here to here, and if I ask you, can you not find the sum from here to here? So you can say yes, whatever sum I have from here to here, will just subtract this one and will get the sum from here to here. It is like this. From first horse to fourth horse, the sum is 10. And if I ask you, so from first to fourth, the sum is 10. And if I ask you to find the sum from second to fourth, so without recalculating, can you say me? So yes, from first to fourth is 10. So from second to fourth will be total first to fourth minus first. So if I find first to fourth, and if I subtract the first, we will get second to fourth. And you can see also 10 minus 2 we will do, then we will get 8. And here it is 8. 1 plus 3, 4, 4 plus 4, 8. So no need to recalculate. Now we know that we will find the answer from here. So up till here we have already the sum 8. Now just we will see that after adding this one, still we can afford or not. So 8 plus 4, 14. It means we cannot. So again we will start from here, and again we will use sliding window. So this is called sliding window. So initially you can red line, you can see this is one window, and now we have slided that window and started from second. That's why sliding window. So I hope it is clear. We are just sliding the window, and so that we can already have the sum. No need to recalculate. It will enhance our time complexity. Sorry, it will reduce our time complexity. Okay. So this is the logic. Now again we will not calculate, we will just add this one and we'll see sum is within the limit or not. Again we will move this window, and again we will do the same thing. So I hope it is clear. Now we will see how to code this. So let us go through this is the code, simple one, nothing to worry. So this is the code in Java. I have already discussed the code in Python and C++. So this two line will basically take the input n and k. This is the array, and it will take the input price of all the horses, and this is sum one, which will store all the sum. Count will basically count the length, how many horses are there continuous. This max length is final answer that we will keep on seeing. Now one by one we will go through the for loop, and we will try to see whether after adding the element still we have sum less than k or not. If it is less than k, we will add it, increase the count. If it is not, we will remove last element, that is slide the window, and we'll add current element. So let us see with the help of here. So Bob will start from first element 30, and we'll check, okay, after I including this one into our sum1 variable, so the sum will be 30, which is less than 100. It means I can include this. So now our sum will be 30, and count will be 1. So 1 element is there, and max length. For max length we compare it with count. If count is greater than max length, it means we got a new max, so that will be our new max. So suppose now I have count equals to 5 and max length equals to 2. So now we got new count, new max, so that we will store here. So initially we have max length 0, and now we got another maximum value. So I will update this because we want maximum. Now sum is 30. Now we will start with this one, and we will check. If I include this, can the sum be still less than k? So 30 plus 40 is 70, which is less than k. So I will include this. So now our sum will be 70. This count will be 2. Max will be 2. So now our window is this one. Now we will see, okay, can I include this also in our window? So 70 plus 50 will be 120, which is greater than k. So I cannot. The moment I find that I cannot, I will remove this from the window and start our window from here. Okay. So same thing we will do. We will remove this one. So with the help of code, it will see this one, a of I minus count, which is basically a of I minus count. So now I is 0, 1, 2. This one 2. 2 minus count. Count is 2, which is a of 0. 2 minus 2 is 0. So a of 0 is this one. So basically it will remove this one only. So this one we will remove from our window. So our window will start from 40. So the moment we have removed this, sum will be decreased. So 70 minus 30, which is 40. So this is our new window. Now our window started from 40. And we will include this also, plus AI. This one also we will include in our window. So now 40 plus 50 is 90. And still the count is 2 and max length is 2. So now we will try to add this one into our window. So 90 plus 20 is 100. And we want it to be less than 100. So it cannot be included. Okay, so 40 plus 50, 90, 90 plus 20, oh sorry, 40 plus 50 is 90, 90 plus 20 is 110. So which cannot be included here. So what we will do? We will remove our last element from the window. And now previously the sum was 90 because 50 also we had added. So previously the sum was 90 because this is the new window it had. And now we will subtract 40. So it will become 50 and we will add 20 because we are subtracting also and adding also in the same window. So now it will be, after subtracting 40 it is 50 and adding 20 it is 70. So this is our new window, 50 plus 20, 70. And count will remain 2, max length 2. Now we will see, can I include this also? So 50 plus 20, 70 already we have. And if I add 20 to it, it will be 90, which is less than k. So I will include this. So now our sum become 90. And count will be increased. Because if we can include this, count is increased. Count plus 1. So now our count will be 3. And since count is greater than max length will also be 3. So now this is our new window, 50, 20, 20. Now we will try to add this one, but we cannot. The moment we find that we cannot, we went to else block. So 50 will be removed. So 90 minus 50, which is 40, and 10 will be added. So this will be our new window. So it is 50. Okay. So this is our new window. And again, we will add this one. Cannot be possible, again we will remove it. So in this way we will keep on moving. Okay, so this is the method of sliding window. We will keep on adding the element. If it is less than k, we will keep on adding. If it is not, we will remove the last element from the window and will add new element. And in this way it will continue. And after that we will check, did I get something max, then current max. If we got anything maximum, we will update. Okay, so this is the code all about, and this part is basically just for that it is basically given to exclude some of cases. Like suppose we have only one horse and the amount Bob has is suppose 10 rupees and the price of that horse is 100 rupees. So he cannot put money on it because he has only 10 rupees. But he cannot remove anything also because nothing we have now. So currently we have nothing in the sum. So in that case, basically it is given. Up till someone is not equals to 0, that is, it is not the previous first case, we will, because there is nothing to subtract, because we have no sum at all. When we are subtracting, when we some has been accumulated, some element has been added to our window, then only we subtracted something. But initially if someone is 0, it means there is no window at all. So how we will subtract something? Okay, like this one. So for that only it is just given, there is nothing else. Every other logic is same. So this is all. And at last, let me recap. So idea is simple. We started from 1 and we have seen how far we can go. The moment we find that we cannot go any more, so now our window will start from next element. So just we remove the first element, now window started from next element. The moment we find that it is also not possible to move further, again we remove the last element and then continue. So this is sliding window, and I hope this code is also simple. There is just 2 if else, nothing more. So this is all from my side, and I hope I have made you understand. If not, try to watch the video again, and if you have any doubt in any part of the code, you can put in the comment section. Okay, so that's all from my side, and thank you guys, take care.